equations in fractional settings. So the type of equations we're looking at would be x over 3 plus 3/4 equals 5/6. Now, rather than finding a common denominator, we're going to multiply both sides by the least common multiple, so we can get rid of those annoying denominators. So one way to think of this is instead of finding a common denominator, you're instead going to use that as a least common multiple, and you're going to use that to multiply through and get rid of all these denominators. So what I mean is it'll look like this. Now think of what the least common multiple is for 3, 4, and 6. Another way to think of that is what would be the best common denominator, even though you're not going to use that as a common denominator. And so what you want to do is multiply both sides by 12. So what that'll look like initially is this. But then you want to be very careful to distribute the 12 to every term. And so it is helpful to write it out like this. Don't skip this step. This step is really valuable. And then what you'll have is you'll be able to cancel through. And so you're going to cancel the common factors in the same way that you would cancel with any multiplication. So here's where we are. Again, don't skip this step. Take your time to write this out. And as you can see, the 12 and the 3 cancel. I divide them each by 3, and I get a 4 and a 1. My 12 and 4 are going to cancel. I divide them each by 4. And so I get 3 in the numerator and 1 in the denominator. And finally, the 12 and 6 cancel. I divide them each by 6, and I get a 2 and a 1. Now, I want to be careful to multiply everything that remains. So the 4 and the x will all be over 1, so I'll just get a 4x. Notice how my denominators disappeared. So 4x plus 9 equals 10. Now I can solve for x. There's no denominators. It's great. Here's another example coming up. So I get this can be kind of complicated, but it's actually quite liberating. Because we can do anything we want to the equation as long as we do it to both sides, we can find ways to annihilate the denominators, which means to obliterate, to get rid of. So really, we never have to deal with fractions ever again, sort of. So here's another one. This is a little bit different because we have two terms in the numerator here. The tricky part here is remembering to distribute the 3, and you'll find out where that 3 comes from. We have to distribute a 3 to both terms in the x plus the 1. So again, I have 3, 4, and 6. What would be my LCM? I want to multiply both sides by something that will cancel the 3, the 4, and the 6. I want to cancel all the denominators. I want to exterminate them. So instead of finding a common denominator, I'm actually multiplying everything by that common denominator. That's going to get rid of all my denominators. So the 12 and 3 cancel, and then the 12 and the 4 also cancel. And here's the 3 that I was talking about that you'll need to distribute. The 6 and the 12 cancel, and we get a 2 in the numerator. So now I just want to make sure that I'm multiplying everything through. And notice that my denominators are all 1. And so I get 4x plus, and remember, you want to distribute that 3 to both the x and also the 1, giving you 3x plus 3. The 5 times a 2 gives you 10. And now you have converted this fractional equation into an equation that has no denominators, and it's much friendlier. So the tricky part for this one is remembering to multiply both sides by your chosen denominator. In this situation, I would want to look at the 3, the negative 3, and the 2. I'd want to get rid of those. So what's my least common multiple? That would get rid of those. And I need to make sure to be careful about this negative. And also, remember, multiply both sides by your chosen denominator. So don't forget, we want to multiply this by 6 and this by 6, but you also have to multiply this by 6 also. So this is what it'll look like. We're going to multiply everything by 6. That seemed to do that fast, didn't it? So this 6 canceled with this negative 3. I divided them both by a negative 3. leaving a negative 2 right here. So this became a negative 2x. I multiplied the 6 by this 2, and I got a 3, and I multiplied the 3 by a negative 1, giving me negative 3. And then don't forget the 5 times the 6 also. Here's another fractional equation. Don't forget to multiply each term by 2, even the whole number that stands alone. So what I'm talking about is this 3. Just because it doesn't have a denominator doesn't mean you're not going to multiply that by 2. The rules are, if you multiply both sides by 2, it's fine, as long as you do it to every term, and that includes the 3. So here's what it would look like. I would want to multiply everything by a 2. And I'm going to be careful when I'm dealing with this negative on this first term. Again, this is a really valuable step. Feel free to write this out and give every single term a 2 to multiply by. It's really helpful. Writing it out like this helps avoid any common careless errors. So when I cancel this 2 and this negative 2, what's really happening is I am dividing them both by a negative 2, which makes the 2 become actually a negative 1, and the negative 2 just becomes a 1. So that gives me this negative times the x plus 1. Be really careful about preserving your parentheses there. In my next term, my 2's will cancel, and I'll just get a friendly negative 1. And then in next term, my 2's cancel again, no negatives, nice and easy. And then finally a 3 times a 2. There's no canceling because that 3 never had a denominator. And so once I distribute that negative to those x plus 1 in parentheses, I will get the following equation. And now I can go ahead and solve.